All right, so I'm going to work on homework for section 8.2.1. This is finding confidence intervals for the mean when we know the standard deviation of the population. All right, so in here, we're either asked to find the sample size or like the sample size required to estimate a population mean with a given confidence, or we are asked to find the confidence interval. All right, so for this first problem in here, we have, suppose the number of dollars spent per week on groceries is normally distributed. If the population standard deviation is 7, and again, when you have this population standard deviation, this is sigma. So sigma is 7. What minimum sample size is needed to be 90% confident that the sample mean is within $3 of the through population mean? So this within 3 is your margin of error, which is the distance from the sample mean to the endpoints of the confidence interval. But first, to be able to find the sample size, we need to find the C value for the 90% confidence interval. To do that, we need to think about what the C value is. And I'll see if I can actually share my iPad. Hold on a second while I do this. I'm going to talk about this real quick. All right, I'm almost there. I'm sorry, this takes a moment to connect. Come on. There we go. Okay, so let's talk about this. Let me fix this template because this spacing is too much. There we go. All right, so let me just reopen what we were doing. All right, so we're working with a confidence interval of 90%. And we need to find the C value. Why do we need to find the C value? Because the formula for the sample size, which is N, is the C score, and this is the C alpha square that you have seen in other videos. This is the critical value for the 90%. You multiply this times sigma, and you divide this time by the margin of error, and then you take this number and you square it. So that's the formula to find the sample size. So we need to find that critical value. All right, so when we talk about the confidence interval, your alpha, which is this alpha that you see in here, alpha, it's always 100% minus your confidence interval. So then alpha is 100% minus 90%. So alpha is 10%. Right? So then we talk about alpha as decimal point. So then alpha is going to be 0.10. So here's what we are talking about. We're talking about this normal distribution, that it's centered at 0 and it has a standard deviation of 1. Let me see if I can just do this a little bit better. All right. So again, this is my normal distribution. I'm sorry, it's late and I'm tired. So that's my normal distribution. So we need to account for 90% of the data. So then from here to here, all of this, it's 90% of my data, like that. So there, So this is my 0.90%. I mean, my 90%, which is 0.90 as a proportion. So then we talk about the tails, which is this part in here and this part in here. I need to distribute the rest of the 100% in between the two tails. And that is pretty much why we talk about alpha over 2 in here and alpha over 2 in here. So if we think about, we have covered 90% of the data set. So we have 10% left. So that 10%, I am going to distribute 5% here and 5% here, right? So then when we talk about the z-score that we are trying to find, we are trying to find this value here, that the value in the distribution that marks that 5% for the tail. So then what I'm going to do is I'm going to go to RGuroo and I'm going to use that normal distribution calculator. And I'm going to use a mean of 0. I'm going to use a standard deviation of 1. And then I am going to find the value for the upper tail covering a 0.05, which is this 5%, all right? So this is something that we do in RGuroo. And I don't know if I have RGuroo installed in here. I mean, not installed, but open. Let me just, let's go here. All right, so then we go to the probability simulations to get to our calculators. So we go to the probability calculator and we go to continuous, because the continuous is the one that has the normal. We have the probability, so we want that probability of 0.05 in my upper tail. So we're working here. We have a mean of 0 and a standard deviation of 1. We are going to talk about upper tail having that 0.05, which is the 5% that it's left on that tail. And I'm going to do the graph to show you what we're doing. So this is kind of what I was doing before. And actually, I can do between tails. So I want 0.05 on the lower tail and 0.05 in the upper tail. And if I do that, then you can see this better, because this is the same graph I had in my iPad. So this in yellow here is that 90%, which is, you see this in here, the probability from minus 1.645 to 1.645 is the 90%. So from this value to this value. So the value that we're looking for is that critical point. And that critical value is this 1.64. So again, if we go here, the z value that is going to help me find the sample size for using 90% confidence interval, it's going to be 1. And let's see if it says rounded to something. It doesn't. So I'm going to do 1.645. All right. And let's see. Okay. So that's how you find those C values. Again, you always need to recognize who your confidence interval is. And then to 100%, you subtract this value. And then whatever you get, you divide by 2, because you need the same amount for each of the tails. And then that is the value as a decimal that you will write in here and in here. So you have the lower tail and the upper tail both having 5% of your data set, which is this tail in here and this tail in here. All right. And so if we move on, it's the same problem. So we are doing the same thing, and we are finding a 90% confidence interval with the population standard deviation of 7. We want the sample mean score to be within 3 points of the true population mean, and that z-score, it's 1.645. So again, I'm going to move to my tablet because I'm going to work on that by hand. Let's see if this doesn't take just like first time. Always takes too long. I'm waiting on my end. There we go. Okay. So we found that. So we found that the z of alpha over 2, which is the z of that 0.10 divided 2, which is z of 0.05, is 1.645. All right. So now the formula, I shared that before. So now that we know this critical point, then we are ready to find our value. So then going back here to work on this, we know that that value is 1.645. We know that the standard deviation of the population is 7, that was given to us. And we know that the margin of error is 3. So we're going to use all that, use our calculator, and then square. So I'm going to do that in my calculator. So 1.645. And now we actually, well, yeah, I don't want to jump into, I don't want to move to another, I want to stay here. 1.645 times 7. I'm going to divide that by 3. I got 3.8383333 repeating. And then I'm going to square that. And I got a 14.73. All right. So then when we work on this, we need a sample size greater than this all the time to ensure that we have the margin of error that we want. So then the end value that we are going to use is actually 15. So you go to the next whole number. All right, I'm not rounding. I'm not doing this 15 because of the 14.7. No, I am rounding because I cannot have a point something of a person. So even if I get a 14.3, I cannot survey 0.3 of a person, right? I need to survey a new person. So I need to go all the way to 15. So then if we go back here and we enter the 15 that we got before, that's the right answer. And then again, remember, I round to the nearest whole number. So I need to go all the way up to the next whole number to ensure that I have the margin of error that I need. All right. So this one, it says, suppose scores of a standardized test are normally distributed and have a known population standard deviation of 6 and an unknown population mean, right? The population mean is going to be unknown because that's what we are estimating. We have a random sample of 22 scores, and from there, we have a sample mean of 92 points. We need to identify the parameters needed to calculate the confidence interval at a 98 confidence interval, and we are going to use RGuroo to find that confidence interval. All right, so let's see. This is X bar is going to be the mean for our sample, so that is a 92. Sigma is the standard deviation of the population. So remember, if you know that, that's sigma. So this in here is going to be 6. We have a sample of 22 scores. So then N is going to be 22. And we use that information to calculate the confidence interval. So now we are finding confidence intervals in RGuroo. To find the confidence interval, we are going to analytics. And then in the drop-down menu, we're going to choose mean inference. And for now, we only have one population. It's just one sample of 22 scores. So we have one population. All right. From here, we need to fill this out. So sample mean is 92. Sample population standard deviation is 6. And we have a sample size of 22. All right. Here it says confidence interval. So the confidence level that we want is 98%. So we just change that to be the same as our problem. Now here is the important piece. When we know the standard deviation of the population, we use a Z statistic. So we need to click in here. So whenever we are working with a problem where we know the standard deviation of the population, we are doing a Z statistic. That's our method to calculate the confidence interval. And this, what this is doing is calculating that Z score for us for a 98% confidence interval, so we don't have to do it. All right, so we go here. Oh, we need to label, I always forget. We need to label this in here. So we are talking about mean of scores for standardized test. And so now we go here, we click it. And so we have our upper and our lower and upper level for the confidence interval. So we're talking about this two in here. So then it says to round to 2 decimal places. So I'm going to use 89.02 for my lower, and then my upper is going to be 94.98 if I round. And then we click submit. All right. So again, this is the mean for the sample, which is the 92 that was given to you in the problem. Sigma is the standard deviation of the population, again, given to you. N is the sample size, again, given to you. And then you use that to plug it into here. And I'm going to open this again. A sample mean is 22. We don't know the sample of the standard deviation because we don't know the sample of the we don't know the standard deviation of the sample because we know the standard deviation of the population, which is the 6, and we have a sample of 22. We change the confidence level to whichever the problem is asking us to do. Remember, this is just the width of that area under the normal curve that we want to cover. And then we use the Z statistic when we know the standard deviation of the population. And then you click in the blue eye, and then yes, I know, and then this is going to be your answer. All right. Okay, so how do we make an interpretation of this? All right, so we have a 98% confidence interval. We have our limits from 89.02, 94.98. What does this really means? What we're doing here is we are estimating the true mean for the population because we don't know it, right? So we say that the true population mean score, like the true mean score for the population, it's between 89.02 and 94.98. And we said that we can estimate that with a 98% confidence, right? So then it is not that we can estimate 98% of the time that the test is taken, a student is going to score between these two numbers. No, what we can estimate with a 98% confidence that the mean, the true mean of the population is between those two scores. So that should be the correct answer. All right, so again, remember that what you are doing with the confidence interval is you're trying to estimate the true population mean. So the your estimation is that the true mean for your population is between these two numbers with the certainty like of the confidence level that you are using. All right, so here's another example to find the sample size. So it says the population standard deviation for the number of emails an individual gets each day is 94. So again, I'm going to do this by hand. So I am going to take notes on the iPad and then I'll switch. Population standard deviation. So we know sigma, it's going to be 94. It also says that if we want to be 90% confident, so our confidence level is 90%. That the sample mean is within 17 emails. So within means the margin of errors. It's 17. We need to calculate the minimum sample size that should be taken. And we need to round to the nearest whole. All right, so again, I'm going to try to share this iPad again and see if it doesn't take forever. I'm waiting. There we go. Okay, so this is the information that we have. So again, let's just talk about that confidence interval. So remember that confidence interval, how it's built. We have the sample mean in the center, and then from there, we go some amount to the right and to the left. That amount is the same, and it's the margin of error. Right? And this in here, it's we call that X bar our point estimate. So when we create the confidence interval, we start with our point estimate, and we add and subtract our margin of error. And the margin of error is the one that has the confidence level and the standard deviation. So the formula for that is the point estimate plus minus the z-score, and then sigma over the square root of n. And this part in here should look familiar. This right here, it's coming from the central limit theorem. Which is chapter 7, which is the standard deviation for the sampling distribution of means. All right, and then the z is like the one that I did before here, that we use RGuroo to find the critical values. So that's how you find the confidence interval by hand. All right, so let's back up. I just wanted to show you what is this margin of error of 17. So it's telling you that from the point estimate, we're going 17 units to the left and 17 units to the right. So then all this thing, it's 17. And this is where that formula to find the sample size is coming from. All right. It's just a little bit of algebra, but I'm not going there. So again, formula to find the sample size is going to be that z value times sigma over the margin of error and everything squared. So we need to find who is this z-score, and we did it before because it's a 90%. So actually our z value is the same 1.9445. This is a 5. 945. Let me just, I'm going to check on the calculator what we got. 1.64, sorry. 645. So it's the same as this one because it's again a 90% confidence interval. So we're doing exactly the same thing. All right. So then let's go back here. We have 1.645 times sigma, which is given as 94, over the margin of error, which is 17. And whatever we get, we square that. So I'm going to do it in my calculator again. So this is 1.645 times 94 divided by 17. I got a 9.09588. And then if I square that, I get 82.735. So again, we need to round this to 83 as our minimum sample size to ensure that we have a margin of error of 17. So if I go back, that's an 83. I'll do 83. Oh, wait. It says minimum sample size. Yes. So that's 83. All right. And then I'm sure that if I do this, so this is another one to find sample size. And again, it's a 90% confidence interval. So it's going to be the same thing that we just did. So I'll do it real quick to move on from this one. So it's 1.645 times the standard deviation of the population, which is 155, divided by the margin of error. So within 47, and then I square that, and this should be 30. So let's see if I did that correctly. All right, so again, it's 1.645, which is the Z, times the sigma, which is the standard deviation of the population, is 155. And then I divide that by the margin of error, which is within 47 emails. I get a 5.425. And then I square that, I get a 29.43. 90% confidence interval. Oh, it's the C value. Oh, it's just a C value. So it's 1.645. All right, it's just a Z score. I was finding the minimum sample size. All right. And now it's the minimum sample size. It's the same problem. So this should be 30, which is what I was doing before. There we go. All right. Okay. And so we can do one more of this. This is to find the confidence interval. That's why we have an interval in here. It says the finishing time for cyclists in a race are normally distributed with a population standard deviation of 11 minutes and a known population mean. Again, this is normal. This is what we're looking for. This is what we're trying to estimate. If a random sample of 22 is taken and results in a sample mean of 135, we want to find a 98% confidence interval. So then we go back here. You can use the same calculator. All right, we just need to change our values, not this. We can open this up again and we change our numbers. So again, to find this out, maybe I should just do it. We go to analysis. You go to the drop down menu, mean inference, one population, and you get this. Sample mean, it's given to you. It's 135. Population standard deviation, also given to you right here. It's 11. Sample size, random sample of 22, so given to us too. Again, we are doing finish time. It's the label for our mean. We are doing a 98% confidence interval, right? 98. And again, because we know the standard deviation of the population, our method is a z-statistic. So we need to click in here. And so we click it, and we have our lower bound to be 129.54, and the upper to be 140.46. All right, and again, the lower is this value in here. The upper is this value in here, and you round to 2 decimal places as required by Newton. All right. And then last problem. It's a new one. So let's just fill this out. Remember that everything should be given to us. It says the time it takes to edit a successful resume is normally distributed with a population standard deviation of 8 minutes. The population standard deviation is 8. This is sigma. And a known population mean. A random sample of 25 is taken. So we have a sample of 25. And results in a sample mean of 58 minutes. The sample mean is right here of 58 minutes. We use that information to find our confidence interval. So then mean is 58. Population standard deviation is 8. Sample size is 25. We need to find a 99% confidence interval. So make sure to change that. And again, we're still doing z-statistic for our method since we are still know the standard deviation of the population. So we click in here. Oh, we need to time. You always need to label your mean, right? So the lower is 53.88, and then the upper is 62.12. All right, so I hope this is very helpful for you to complete your homework.